Hello, everyone, and welcome. Have you ever looked up at the night sky and wondered, are we alone? As we learn more about the universe, it feels possible that another Earth exists. In this video, we'll explore the possibility of other planets like ours. Get ready to explore the habitable zone and fascinating exoplanets as we dive into the age-old question, are we alone in the universe? Let's begin. Our own Milky Way galaxy, a swirling mass of stars, gas, and dust, is just one of billions of galaxies in the observable universe. Within our galaxy, there are hundreds of billions of stars, each potentially hosting its own planetary system. So, where do we begin to look? Scientists focus on stars similar to our Sun. These G-type stars offer a stable source of energy. They also look for planets in the habitable zone. But even with these criteria, finding another Earth is no easy task. Before we venture further into the cosmos, let's appreciate our own planet, Earth. This pale blue dot, as Carl Sagan called it, is our only known habitable world. Several unique conditions create the perfect environment for life. We have liquid water, essential for all known life forms. Earth's ideal distance from the Sun supports liquid water. Our atmosphere, mainly nitrogen and oxygen, shields us from harmful radiation. Earth's magnetic field deflects harmful solar wind, protecting life. So, where do we even begin to look for planets like our own? It's like finding a needle in a cosmic haystack, right? Well, astronomers have a starting point, the habitable zone. Imagine a star like our Sun, radiating warmth and light. Around this star is a band, a sweet spot where temperatures are just right for liquid water. That, my friends, is the habitable zone. Finding a planet in the habitable zone is just the first step. But for now, the habitable zone gives us a place to start our search for other Earths. The habitable zone is often called the Goldilocks zone. Remember the story of Goldilocks and the three bears? She wanted porridge that was just right. That's what we seek with planets in the Goldilocks zone. They need to be at the right distance for liquid water. Too close and the water vaporizes. Too far and it freezes solid. Earth sits comfortably within our Sun's Goldilocks zone. We have oceans, lakes, and rivers, a testament to this balance. Finding another planet in a similar sweet spot is no easy feat. Venus serves as a stark reminder that being in a star's habitable zone doesn't guarantee a planet will be hospitable. Venus circles our Sun within the outer edges of the habitable zone, closer than Earth. Venus is often called Earth's evil twin. Despite its potential, Venus is a scorching, hot, toxic wasteland. Its thick atmosphere traps heat in a runaway greenhouse effect. Venus's story is a cautionary tale in our search for another Earth. It shows that even a planet in the habitable zone can be hostile to life. Mercury, the smallest planet in our solar system, is a study in extremes. Surface temperatures can reach 800 degrees Fahrenheit, hot enough to melt lead. At night, temperatures plummet to minus 290 degrees Fahrenheit. These wild swings make Mercury unlikely for life. Mercury serves as a reminder of the delicate balance needed for habitability. We've explored a few planets in our solar system and seen how they measure up to Earth's. Finding another planet capable of supporting life is no simple task. Scientists have clever methods to narrow down the search. They look for planets within the habitable zone, where temperatures allow liquid water. Size matters too. Small planets struggle to hold atmospheres while large ones might be gas giants. Analyzing light from distant stars, scientists learn about planets' size and atmospheres. The stars hold secrets to the planets they harbor. Astronomers use the transit method to find exoplanets. A planet passing in front of its star causes a tiny dip in brightness. This dip reveals a wealth of information. We paint a picture of distant worlds, one star at a time. When searching for planets that could support life, size truly does matter. A planet's size affects its gravity, influencing its ability to hold on to an atmosphere. Too small and the atmosphere could drift off into space. Too large and it might trap heat, making the surface unbearably hot. It's all about finding that perfect balance. In the vast cosmic ocean, our Earth is like a tiny precious pearl. Its size is a key part of what makes it so special. We use Earth as our measuring stick for habitable worlds. A planet Earth's size can hold an atmosphere. This atmosphere regulates temperature and protects life. Mars, smaller than Earth, lost much of its atmosphere. Size is crucial for a planet's habitability. In the constellation Libra, about 20 light-years away, lies a red dwarf star called Gliese 581. Orbiting this star is a planet that has piqued the interest of astronomers and dreamers alike, Gliese 581c. It's about 5 times as massive as Earth and thought to be rocky. Gliese 581c orbits within its star's habitable zone. Temperatures could allow for liquid water to exist. Its discovery is a beacon of hope, a reminder that we might not be alone. What secrets might this distant world hold? In our quest to find a twin for Earth, we've discovered some fascinating planets, and Kepler 186f is a particularly intriguing one. Located about 500 light-years away from us, this planet orbits a red dwarf star called Kepler 186. What makes Kepler 186 of special is that it sits within its star's habitable zone. This means temperatures could allow for liquid water, a crucial ingredient for life as we know it. However, there are still many mysteries surrounding Kepler 186f. Further observations are needed to unlock the secrets of this distant world. While many potentially habitable planets have been discovered, Proxima Centauri b holds a special place in our imagination. It orbits the star closest to our Sun, Proxima Centauri. This red dwarf star system is just over 4 light-years away. Proxima Centauri b is thought to be a rocky world slightly larger than Earth, and it orbits within its star's habitable zone. Conditions could potentially allow for liquid water. Imagine the possibilities if Proxima Centauri b harbors life. However, red dwarfs frequently release powerful flares which could strip away atmospheres and make the surface uninhabitable. The search for life beyond Earth isn't just about finding planets in the habitable zone. It's about understanding the intricate web of factors that contribute to a planet's potential to harbor life. A planet's atmosphere can protect life from harmful radiation or trap heat, creating a greenhouse effect. Another important factor is the presence of a magnetic field. Earth's magnetic field acts as a shield, deflecting harmful radiation from the sun. Geological activity like plate tectonics regulates Earth's climate and recycles essential nutrients. Finding a planet in the habitable zone is just one piece of the puzzle in our search for life beyond Earth. We've all heard of Mars, haven't we? The red planet, our neighbor in the vast expanse of space. While Mars might seem like a dry, dusty desert today, there's growing evidence to suggest that it wasn't always this way. Rovers like Curiosity and Perseverance are exploring Mars, searching for signs of past life. It's a tantalizing thought, isn't it? Let's journey beyond Mars to explore desert planets. These worlds are characterized by their arid, desert-like conditions. Life might thrive in unexpected ways, just as in Earth's deserts. Studying them broadens our perspective on habitable worlds. From the arid landscapes of desert planets, let's dive into ocean planets. Imagine a planet entirely covered in water, an endless blue expanse. These planets form in the outer regions of star systems, where water can exist in its liquid state. They challenge our view of habitability, suggesting life could thrive in different environments. While the immense pressure and lack of sunlight might seem like obstacles, remember, life on Earth began in the oceans. Perhaps in the hidden depths of these alien seas, strange creatures are swimming about, proving that life always finds a way. We spent quite a bit of time talking about planets, but what about moons? They might be smaller siblings to planets orbiting around them, but some moons are far more than just celestial sidekicks. Some scientists believe moons might hold greater potential for life than some planets. While planets get most of the attention, moons, especially those orbiting gas giants, can be worlds unto themselves. Some are gigantic, even larger than Mercury. Moons come in all sorts of varieties, from volcanic powerhouses to icy enigmas. They could be little oases of warmth and potential life. So, as we broaden our search for life beyond Earth, let's not forget to give these fascinating celestial bodies the attention they deserve. Of all the fascinating moons in our solar system, Jupiter's moon Europa stands out in the search for extraterrestrial life. What makes Europa special? Beneath its icy exterior lies a vast ocean. This ocean could contain more water than all Earth's oceans combined. And where there's water, there's the possibility of life. Tidal forces from Jupiter, along with hydrothermal vents, generate heat and energy. These conditions could create a hospitable environment for life. Europa remains one of the most exciting targets in our search for life beyond Earth. When we talk about the conditions necessary for life, we often focus on liquid water and a suitable atmosphere. But there's another crucial factor: Earth's magnetic field. It acts like an invisible shield, deflecting harmful solar wind. Without it, harmful radiation would strip away our atmosphere, making life much harder to thrive. We've talked about habitable zones and Goldilocks planets, but what if we took it a step further? What if, instead of just looking for planets like ours, we looked for stars like ours too? That's where the concept of solar twins comes in. Imagine finding a star that's almost a mirror image of our Sun. It's a pretty mind-boggling thought, isn't it? If a star is very similar to our Sun, the planets orbiting it might be similar to those in our solar system. It's like looking for a familiar face in a crowd. Finding a solar twin would be a major clue, like stumbling upon a treasure map in our search for other Earths. The search for other Earth-like planets leads us to one profound question: are we alone in the universe? The sheer scale of the cosmos makes it seem improbable that we are the only living things out there. Even a tiny fraction of habitable planets could mean the universe is teeming with life. It's a thought that's both exhilarating and humbling. The search is on, and every new discovery brings us closer to answering this question. In our search for extraterrestrial life, we often focus on finding Earth-like conditions. We look for water, oxygen, and carbon-based life forms. But what if we're being Earth-centric? What if life is completely different from anything we can imagine? This is where carbon chauvinism comes in. It's the assumption that life must be carbon-based. Could life emerge from silicon or something more exotic? It challenges us to think outside the periodic table. Imagine life forms radically different from anything we've encountered. The universe never ceases to amaze. So far, we've mainly focused on planets that might resemble Earth, but the universe is full of surprises. Take Titan, for instance. Orbiting Saturn, this moon is colder than any place on Earth. Its rivers and lakes are filled with liquid methane. It sounds like something out of a science fiction novel. But Titan holds a certain fascination for scientists. Beneath its icy surface, there's evidence of a vast salty ocean. And where there's water, there's always a possibility for life. As we've journeyed through the cosmos, exploring distant stars and planets, one question has lingered in our minds. Are we alone in this vast universe? Is Earth, with its vibrant tapestry of life, a unique anomaly? Or could it be that we're simply the first to be discovered? The sheer scale of the universe suggests that the possibility of other life is incredibly high. The conditions that gave rise to life on Earth might not be as exceptional as we once thought. As we near the end of our exploration, we're left with a sense of wonder and a thirst for more knowledge. We've journeyed from the fiery heart of our own solar system to distant galaxies, uncovering the secrets of planets both familiar and strange. We've learned about the delicate balance of conditions necessary for life as we know it, the importance of liquid water, a stable atmosphere, and a protective magnetic field. We've encountered planets scorching hot and others locked in icy silence, each with its own unique story to tell. And while we haven't yet found definitive proof of life beyond Earth, the search continues, fueled by our innate curiosity and the ever-growing capabilities of our telescopes and spacecraft. The universe is a vast and mysterious place, and we've only just begun to scratch the surface of its secrets. But one thing is certain: the search for another Earth, for another planet teeming with life, reminds us of the preciousness of our own world and the importance of protecting the delicate balance that makes life on Earth possible. We've talked about the vastness of space, the potential for other habitable planets. But amidst all this wonder, there's a chilling question posed by the Fermi paradox. Where is everyone? This is where the great filter theory comes in. It suggests that somewhere on the long path from lifeless matter to advanced civilizations, there's a hurdle so difficult, so improbable, that it filters out most life forms from ever reaching that point. It's a sobering thought that lingers as we continue our exploration. The silence of the universe is a mystery. What if it's a deliberate silence? The zoo hypothesis offers an intriguing answer to the Fermi paradox. What if advanced extraterrestrial civilizations are observing us from a distance? The idea is that we're not ready for contact, too young and volatile. It's a humbling thought. The search for other Earth-like planets, for signs of life beyond our own, is a journey of incredible scientific endeavor. It forces us to confront our place in the universe. We may be a long way from answers, but the quest will continue to inspire and challenge us.